What's up, Chem 30? Welcome to your first online Chemistry 30 lesson. Hopefully this doesn't go too terribly. You're going to need a couple of things. Make sure you got your notes. Make sure you've got a screen to watch this on. Hopefully, probably bigger than your phone. I'm guessing a lot of the writing's going to be a little small if you're trying to do it on your phone. Maybe it works for you, I don't know. We'll all have to adapt a little bit as we go along. And if something's not working, please let me know, and I can adapt and try and change things up so they work better for you in the future. But make sure you got your notes, make sure you got your data booklet. You're probably going to need a calculator for some of this. Nothing major, but there's some calculations we're going to have to do. And that's it. So let's jump in. So here's lesson 8. I'm going to try to keep each of these videos short and sweet, so hopefully they're not too painful to deal with. But on this one, you can see you've got a bunch of objectives here. Those won't make a lot of sense to you for right now, but that's kind of the goal of where we're trying to get to. Is a lot of these terms you're going to be able to know. You'll be able to identify the similarities and differences, predict the half reactions that occur at each electrode in an electrochemical cell, and then calculate the cell potential for each of these. I'm probably going to break this up and to do 4 separate videos, or at least 3, to kind of walk you through those objectives. So each lesson maybe will be broken down similar. I don't know, like I said, we'll just have to wait and see how this all goes. Now, just to begin with though, for this one, let me just show you some of these key terms and kind of what we're working on here. So right here, you've got 4 terms. Let me just slide that down up a little bit. 4 terms that help you, there, that's better. 4 terms that are going to help you understand a lot of the things in this unit. So these are absolutely essential terms. You're going to use them all the time, and if you don't understand them, it's going to cause you problems. So the first one here is the electrode. Okay, so an electrode, let me pick a color here. An electrode is a solid electrical conductor. So if we were to look at this diagram up in the right, you can see that there's a copper electrode right here and a zinc electrode right here. Okay, so those 2 things are electrodes. They're just solid chunks of metal. Okay. The next is the electrolyte. Hopefully you remember electrolytes from Chem 20. Electrolytes are things that conduct electricity. They have to have ions. So the electrolyte is usually, not always, but usually it's an aqueous solution. And specifically the big one is there needs to be ions present in order to allow charge to move around inside the cell so that things will work. Okay. In our case, that electrolyte is going to be in here. Now, you don't have to draw these if you don't want to. This is just to help you understand what's going on. These solutions have the electrolyte in them. Okay. Now, there's also some electrolyte in this salt bridge as well. So I should draw some of that in there for you. Okay. The next one is the external circuit. The external circuit is the path where the electrons actually are going to travel. So in this case, it's the wire, and it's external. So we're not talking about electrons flowing inside the system. We're talking about it flowing from this side, let's say, for example, the zinc electrode over to the copper electrode. It's through that wire. That's the external circuit that we're talking about. Now, inert electrode I can't draw on this diagram because it doesn't have one, but inert means that something doesn't react. So, for example, we have 2 electrodes in this one. We have copper and we have zinc, but some half reactions don't have those. The copper-zinc half reactions each have ions and solids. But what if you had a reaction that was an aqueous ion on one side and a gas on the other, or an aqueous ion on one side and a different aqueous ion on the other side? In those cases, we have to give a solid electrode, a chunk of metal for them to use, but I don't want to give them a solid that's going to mess up the reaction. I don't want to be a stronger OA or RA than what's already there. The easiest way to get around that, rather than go through your table and try to find an appropriate solid, is just to use one that I know will not react. And that's what these inert electrodes are. They're just completely inert. They do nothing. So the two that you need to know are carbon and platinum. So if you ever needed to do something with a cell and you needed an electrode, but the half reactions didn't provide one, the safest bet all the time is going to be either pick carbon or pick platinum. Out of the two, I would say most of the time we pick carbon just because it's a heck of a lot cheaper than platinum. But there are some reactions that work a little better with platinum. But either one will work, and neither one of them will ever mess up with or mess around with your reaction. So, all right, so this is the first video. At least gives you an idea of the basics of where we're going to go and what this might look like. And we've gone through some of these key terms. Now, we've done maybe part of that first objective, at least a couple of the terms there. When we go through the two cells in your notes next, we will cover the rest.